Hello, I am Sid. I'm gonna be your guide for the S-Planet tour. In this video, we will cover chapter 1st, from your N.C.E.R.T. science textbook, of class 9th, that is, matter in our surroundings. Let's start the unit by saying, S-Planet, here we go. As we look at our surroundings, we see a large variety of things, with different shapes, sizes, and textures. Everything in this universe is made up of material, which scientists have named as matter. That means everything in our surrounding, like air, water, food, clouds, stars, sands, everything is made up of matter. This is how matter surrounds us. This matter evolves two types of properties: physical properties and chemical properties. Well, in this chapter we will learn about physical properties. Well, in physical properties, firstly, we will see the physical nature of matter. As you all knew, matter is made up of particles. But these particles can either be arranged in a continuous structure like wood, or in a particulate structure like sand. This doubt can be solved by performing an activity. In this activity, we will require a beaker, water, and salt. Let's start the activity. Take the beaker and fill it with water. Now, add a spoon of salt. Later, you will observe that salt get dissolved in water, because the particle of salt get into space between the particle of water. As a result, we can say that matter is made up of particles. Here arises another question. How small are these particles of matter? This question can be answered by performing an activity, in which we will require 2 to 3 crystals of potassium permanganate salt, which we need to dissolve in 100 ml of water. Now, take out 10 ml of this solution, and put it into 90 ml of clean water. Repeat it twice or thrice. Later, we will observe, just a few drops of potassium permanganate solution can color a large volume of water. As a result, we will get the conclusion that the particles of matter are very small. They are small, beyond the imagination. Particles of matter holds some characteristics. Let's understand them. First characteristics says, particle of matter have space between them. In above activities, we observed that particles of salt get into space between particles of water. And also particles of potassium permanganate get into space between particles of water. This shows that there is enough space between particles of matter. While the second characteristic says, particles of matter are continuously moving. To prove this characteristic, let's perform an activity. Put an unlit incense stick, or you can say, agarbati, in a corner of a room. Now light the incense stick. From this activity, you will observe that when the incense stick is unlit, you need to go close to it to get its smell. And when you lit incense stick, its smell spread all over the room. From this we understood that the particle of matter moves continuously, and on increasing temperature particles move faster. In above activity, you had observed that particles of matter intermix on their own with each other. This characteristics of matter is called as diffusion. Another characteristics of matter says, the particles of matter attracts each other. Let's perform an activity to prove this characteristics. You all have tap in your home. Put on the tap and try breaking the stream of water with your fingers. You will observe that the stream of water remains together. From this, we can say that there is force acting between the particles of matter, which keeps the particles together. Apart from characteristics, states of matter is also a physical property of matter. These states of matter arises due to variation in the characteristics of particles of matter. Matter exists in three different states: solid, liquid, and gas. Let's see them in detail. The first state is the solid state. Solid state of matter is possible when the particles of matter are tightly bonded to each other, so that no other thing can passes through it, like wood. Let's see an example by performing an activity in which you will require pens, book, and a needle. Sketch the shape of any structure in your notebook by moving a pencil around them. Draw up these structure from a height. Firstly, they all have a definite shape. And secondly, they do not diffuse when dropped from a height. As a result, we found that solid state have properties like definite shape, distinct boundary. Whether you put them in a jar or on a table, their shape do not change along with their fixed volume and negligible compressibility. The next state is liquid state, in which the particle of matter are separated from each other. The bond between the particles is very loose. Let's perform another activity to understand liquid state. Take water into a beaker and marked up to 50 ml. Now, pour water into another container of different shape, also marked up to 50 ml. You will observe that liquid do not have definite shape, they take the shape of container. But they have fixed volume. So from results we can say, liquid do not have finite shape. Liquid have fixed volume. And liquid can easily flow. But what about diffusion ability of liquid? From the previous activities, we have seen that solid and liquid can diffuse into liquid. But, you know what, gases also diffuses into liquid. Diffusion of oxygen and carbon dioxide are essential for the survival of aquatic animals. Thus, we can say that solid, liquid, and gases can diffuse into liquid. The rate of diffusion of liquid is higher than that of solid. This is because the particles of liquid moves freely and have greater space between them as compared to particles in solid. And the last state of matter, that is, gaseous state. Let's see the properties of gaseous state. They are highly compressible, and they have high rate of diffusion. Now, we need to understand the reasons why gases are able to hold these properties. First of all, let's understand why gases are highly compressible. Since particles in gaseous state have large space between them, therefore, they can be compressed as much as possible. For example, the liquefied petroleum gas, LPG, is a compressed gas. That is, a large amount of gas can be compressed and can stored in a cylinder. Secondly, why gases have high rate of diffusion. Since there is large space between particles, other gas particles can easily get mixed between the gas particles. For example, you come to know of what being cooked in kitchen, without even entering there. As you had seen, the states of matter. Now, it's time to see how matter changes its states. Water is the best example to see the change in the state of matter. Ice is the solid state, while water is the liquid state, and vapor is the gaseous state. The change in the state of matter happens with the change in temperature. At the room temperature, water is in the liquid form. When you increase the temperature, it starts to boil and change its states to vapor. While, when you cool down the temperature of water, it becomes ice. This is like a reversible cycle. This is due to effect of change in temperature. Ice become water, and then become vapor, when heating. And reverse can be seen, while cooling the vapor, it become water, and then ice. But, what happens to particles of matter during the change of state? With the increase in temperature of solid, the kinetic energy of particle also increases. Due to increase in kinetic energy, the particles starts vibrating with a greater speed. Energy supplied by heat overcomes the force of attraction between the particles. As a result, particles starts moving more freely. Hence, solid get converted into liquid, and then into gas. Now, let us learn some new terms. First, melting point. The temperature at which a solid melts to become liquid, at the atmospheric pressure, is called its melting point. Second, fusion. The process of melting, that changes solid into liquid state, is known as fusion. Before moving on to next term, let's us study our previous observation in little detail. It has been observed that, when ice is heated, heat energy is absorbed by ice. But, the heat energy supplied to ice is not been used to rise the temperature of ice, but to break the force of attraction between particles. On the basis of this observation, new term was introduced. Latent heat. Heat supplied to ice does not show rise in temperature. It is considered that it gets hidden into the content of beaker, and this is known as latent heat. Next term is boiling point. The temperature at which liquid starts boiling at the atmospheric pressure is known as its boiling point. While vaporization is the process of change in the state from liquid state to gaseous state. And sublimation, it is a change of state directly from solid to gaseous state without changing into liquid state. In these terms, you may have noticed that some terms works with respect to pressure quantity. Now, let us understand the effects of change of pressure. By applying pressure, particles of matter can be brought together, and hence, the state of matter can be changed by changing the pressure. Evaporation will help you to see the effect of pressure. The phenomenon of change of liquid into vapor at any temperature below its boiling point is called evaporation. It can also be explained as when liquid changes to vapor without being boiled is known as evaporation. For example, when we put clothes out for drying them, the water in clothes changes to vapor without being boiled. Let us see mechanism behind the evaporation. It is a surface phenomenon. When the particles of liquid at surface, having some kinetic energy, is able to break away from the force of attraction between particles and get converted into vapor. This is how evaporation occurs. But there are some factors affecting evaporation. The first factor that affects evaporation is surface area. On increasing the surface area, the rate of evaporation also increases. For example, we use to spread clothes when we put them for drying. Spreading clothes provides larger surface area, so that the rate of evaporation increases. As a result, clothes dries faster. The next factor that affecting evaporation is temperature. On increasing the temperature, more number of particles get the kinetic energy to change its state. For example, wet clothes get dried soon on sunny days. Humidity in the atmosphere also plays an important role in affecting evaporation. Humidity is amount of water present in air. The air around us also holds some amount of water in vapor form. So, if amount of water is high, rate of evaporation decreases. Now the last factor which affect evaporation is wind speed. Wind speed moves away water particles. As a result, water vapor in the surrounding decrease, and evaporation increases. This is how we are surrounded by matter. Here ends the chapter from your N.C.E.R.T. Class 9th textbook, that is, matter in our surrounding. If you get the complete knowledge of the chapter, please tell us by liking the video. For any doubts, feel free to write in the comments. It's always open to help you. And do subscribe for further lessons.